Hey, welcome back into the channel. Hopefully you are sticking around and make sure you like or subscribe. We're looking at how people are looking at motherboards, how people are fixing motherboards and common problems that they have. And so we get some ideas on how we can fix motherboards and we can do certain things. And we, at this moment, at this time, I am in the mix of fixing a board and it is kind of overheating. And I kind of figure out why my board is overheating. I kind of know I need to add some more thermal paste to it, but that's for another story, another time. But it's just nice to see these technicians, these I call them surgeons, go in there and they are just doing a lot of what do you notice, what do you wonder. And I watch these two technicians on YouTube a lot and just get some ideas of how to brainstorm, what to look for. As you'll see in the video, we'll be pausing it. They're looking at some boards that I deal with and some, what I like about a lot of these, a lot of the procedures that they use are just good common practices that you're going to need to use as you are working on these boards. And the thing about these boards and, you're going to get these error codes on these boards. And so what you're going to have to do is they're telling you, hey, this is not working right. Make sure that you check this and check that. And so that one of the things that we try to do is, the board's talking to you, talk back to the board. So here's one of the cool guys that I like sitting here. Like I said, I've done this before, but I'm just still trying to learn how to do a lot of electronic stuff and the one thing about all this electronic stuff is some of the materials they're using, some of the vocabulary they're using, getting familiar with it. Like I said, I have some experience using this stuff and problem solving, but just getting back into it and learning as I go. And then the more I learn, will take you along the journey. So hopefully one day you'll see me breaking these boards down. That's the more it is just to get familiar with it and doing a good job with it. So, so let's get this on down the road and we should be having a good time. So sit back, enjoy, and should be really interesting to watch him does today.
In this video, we will try to fix an aim-for motherboard from MSI model B550. We will inspect the board with a microscope, identify problems and fix them, hoping it will restore the motherboard to a working state. I will describe the main parts of this motherboard is made from, and moreover, we will try to do all soldering job with a cordless soldering iron. Please watch this video till the end, it should be interesting. Hi everyone, today on the bench we have MSI B550A Pro. This is MS7C56 version 2.3. So this motherboard was very popular during the COVID in 2020. It was released in 2020 and it was a good substitution for office computers in that period. So this board has no Wi-Fi. It has PS2, USB 2, USB 3.2. It has a sound on the board, Ethernet controller, flashback BIOS button. Earlier, these boards had brown PCB background color, but it was changed, as I remember, to a nice-looking gray and black color. So the board has unusual PCB recessed near the SATA headers. It was made for more space for cable management in a computer case. So this board has 10 plus 2 plus 1 power stages. It's 10 phases for vCore, 2 phases for SoC, and 1 phase for VDDP. The VRAM on this board is represented by IR35217 multi-phase controller within the flash memory. So it means that if the controller is damaged, we should flash it with the firmware. The board has on-semi MOSFETs. The upper MOSFET supports 46 amps and lower is 78 amps. The MOSFETs are derived by the IR3598.
And one thing as we get back into this, and if you're just learning like I am, or depending on where you are, like I said, it's various guys who are out there doing this stuff, and it's the vocabulary that they're throwing out there, the lingo that he's using. And what I like about these guys, they know exactly the component parts They know exactly how much voltage each one of these components should be getting at any time. So a lot of times when we're doing these things, we have to know, we have to study these boards. We have to know exactly what this MOSFET's going to do. We got to know exactly when how much power is going to go here, and those are the things that you're going to need to know how to do to make sure that when you're diagnosing these boards, everything is running okay. It just takes time and energy and just sitting down and kind of being like a little detective.
Doublers. There's a 4 doublers on the back and 2 doublers on the front side under this heatsink. The SIO of this board is a Nuvoton NCT6687D. Basically, this is an 8-bit microcontroller which controls the board power-up sequence and overall health of all the peripheral devices on the board. BIOS, 1.8 volts, 16 megabytes chip. Flashback was shipped from FinTech. Well, the location of this chip near the upper PCI Express slot is a reason why it was often damaged, and the flashback button stops working on this board.
As I look at what he's doing here, as I trying to figure out what he's doing, for the most part, what he's trying to do is he's explaining to you like the most common problems with these boards as they've come through. And like I said, a lot of people use these during the office buildings. And so these are the things, a lot of the times when these computers are coming back to you, they're going to have the same common problem over and over again because it's how they're manufactured and how they were made. But the main thing is when he is going through this board, watch how he is checking for certain things and visually looking over the board, and it's pretty cool how he does this.
Today's video is sponsored by FNIRC. They sent me their HS03, a cordless soldering iron. Battery powered, no cable, no station. I wouldn't call this a replacement for a bench station, and I'm not going to review it like one. Where it makes more sense is remote repair, or anywhere you don't have a power outlet. That's a different way of working than what I usually do here. So what I'm curious about is whether a battery iron can actually hold up on real board work. Small resistors under the microscope, ground planes that it hit, that kind of thing. I'm going to use it today for the actual soldering in this repair, and I'll tell you what I think at the end, not before. So let's get back to the board.
As you can see, he's going to use a new soldering iron, and he likes this one because, to be honest with you, sometimes when you are repairing things, you may not be on your bench. You may not be able to have electricity, have some things around. You may be, I know sometimes we have some of these boards that are in some really particular places where you just can't pull them out, and so you're going to have some options along the way. Options are always good for you.
So as usual, let's quickly check the resistances on the main power rails using the ATX 24 pin connector, and we can follow on and make a test power on. So let's start with 3.3 volts.
Up to the top left, you can see he has his little, he has his guide. He has his guide, and we talked about how you have to check these voltages and check these, just the continuity and everything there before you put some power to these boards, because they could short out and they could potentially give you a lot of problems. And then we've seen some boards that people have put in here and they exploded on them. So you're going to have to really watch and make sure that this is one of the first steps that you're going to have to do is just watch and look at. As you can see right here, he has his little guide there, and it tells you which pin and how much power should be getting in these pins, and just with a little simple multimeter.
And we have kilo ohms here, 5 volts, almost like a kilo ohms, no short, 12 volts. Kilo ohms, 5 VSB, 938 ohms, minus 12 mega ohms, no short. Then we'll have 12 volts CPU. Here we have kilo ohms as well, and the 12 volts to V core, mega ohms, 12 volts to SOC, okay, normal. Then we have VDDP, We have a mega ohms as well, 2.5 volts, 1.3 kilo ohms, 5 volts, kilo ohms as well. This is probably 0.6 volts for the memory, kilo ohms. And I guess that's it. So let's try to power it on.
And as you can see, one of the things he didn't mention is he make sure you ground that probe, and as you're looking around and you're looking for certain measurements and continuity or along the board and looking for certain voltage things, make sure you ground that probe so you won't short out your board.
So we're going to use Ryzen 3200G as our testing CPU. So let's press the power button. And we have no reaction at all. Okay, do we have a voltage on the power button? Let's check. And we don't have a voltage? No, we do. Okay, we have 2.3 volts on the power.
I was just talking to someone about this. A lot of this stuff comes back to just, let's say it's a dryer situation where the dryer will, you push the button and the dryer won't get going. And the dryer won't get going. And what happens is you roll the dryer a little bit, and then it'll catch on and it start heating up, and it's kind of like it just needs a little push there to keep it going. So as you look right there, the first thing he's looking at is that start button. Is make sure that the power, when it goes to that start button, why isn't it releasing and going to the next stage? And so very important that you kind of have to know, okay, this is the start button. What comes after the start button? What goes? It's kind of like a little domino effect if certain things go a certain way, and you should be just follow along, and you should be good.
Button. So let's make a visual inspection. We'll try to look, do we have any knocked off components or broken traces? Okay, let's start with the inspection of the board under the microscope. So this is the area near the CPU. And oh my god, what happened was this? Is this just the dirty crystal, or yes, it's just the thermal paste. Okay. So there's nothing critical over here. Let's look at the PCI Express clip. And I don't see any scratches on the PCB layer, so
So what he did was he did his little multimeter check where he had to see if anything was just not shorted out, not working. Next thing he's going through, make sure that there is no physical damage, no broken off components. Those trace lines, make sure there's nothing scratched through there, so that he can say, hey, maybe this is part of the problem. I need to solder this up and that.
This looks good. The BIOS chip definitely was not desoldered from here. Okay, TPM header. Then let's move to the SIO. And, oh, I see that. So we have a knocked off component near the SIO from this side, right here. Another one I see over here. This resistor is actually damaged. I see there's a damage to the package. This resistor is damaged as well, but I'm not sure if it's working or not, so we need to check the resistance. Definitely this one knocked off. This one is maybe damaged, maybe not. I'm not sure.
So as he's going through and looking through it, and one thing that you're going to have to do, one thing that I have to kind of invest in as I get more into this is a good microscope. And these microscopes that these guys are using, when I first started, we were using a magnifying glass. And it kind of was discouraging to use that, but it was a starting point. So as you can see, these guys are having these microscopes to go in there and look at the board a little bit more carefully. And as he's finding, a lot of the resistors are damaged or and whatnot. So it's not. He's getting a clue. One thing that they are doing is I watch these shows is sometimes it may not just be the resistors, but he's going to go ahead and replace them, so that eliminates. Hey, well, I know if I replace these resistors, it's that takes that out of the equation of it being broke. So there's various things that you're going to have to just go through and repair, and hopefully that fixes it.
I think that there's no component right here, but this resistor doesn't look good for me. So we need to check those resistors. They may be damaged and not working, and I bet that it's better to replace them. Do we have any other damages in this board? So this is the RTC area, and the RTC area looks normal. So that's the area of the power button. That's the power connector. That's the memory voltages. The area under the CPU. So those are the PCI Express caps. And they all present. Well, I'm quite concerned about this one, but it doesn't look that there was a component here. So all components here is present. We have a standalone resistor, 2.2 ohms, and it's present and looks good. Okay, so let's check about this resistor. This resistor is R343. This is a 2.5 kilo ohms resistor, and it's responsible for the input of 5ESB DET signal, which is used for 5-volt standby power detection by the SIO. So since the resistor is knocked off, the SIO thinks we have no 5ESB and therefore it does not initiate power on sequence. I guess this is the culprit. This is one of the main resistors which can prevent the board from startup.
So he's found that this is the SEIO resistor is broken off, and sometimes when you're doing these components and whatnot, they're looking for, hey, are you working over there? No, there's nothing there. Until you are fixed, I can't do my part, and that's what it comes down to. It's this motherboard. It's everything relies on certain things to make sure that it's working properly, so it can keep flowing.
And another one right here. Here should be a resistor of 1 kilo ohm, and this resistor is for P80 enable signal for the SIO. I'm not sure what does it mean. This resistor should be 10 kilo ohms, and let's check if it's still alive or not. Let's check if this resistor is okay, and this resistor is 6.7 kilo ohms. Okay. I'm not sure this is because of the damage, but I guess it's okay. There's a knocked off resistor. The knocked off resistor disconnects data path from the audio codec into the CPU. SDIN 0 is how the audio codec talks back to the chipset. Microphone input, jack detection, and every response to a command the chipset sends. So if this line is cut, the chipset asks the codec questions and never hear an answer. So Windows sees no audio device at all. It looks like a dead codec, but the codec is fine. It's just the answer cannot get to the CPU because here we have a broken path. Let's check the resistors. Okay, let's check this. We have 1 kilo ohm here. Nice. 682 ohms. 2.6 kilo ohms, so it's normal. Okay, so this resistor should be 22 kilo ohms, and I have it mega ohms readings on it, so this resistor is damaged. So far, those are knocked off components near the SIO and audio codec, which have to be replaced. We gotta fix this, and then we'll try to power it on again and to see if that was the culprit.
So what he's going to do is, and this is the part that you're going to have to really, and I'm going to have to really practice, is the soldering process. The soldering process, and he's going to use this new little probe, or little soldering iron, and he's got this portable one. And the thing is, he's trying to see if it'll heat up enough, and is it practical to use on job like this. He went back and he tested the resistance of the resistors in there with his multimeter. So it's good. And so when you're doing these boards, make sure when you're soldering and whatnot, make sure that you are having enough make sure that you have the vents open so that the exhaust and the solder doesn't get in your nose. And so make sure you always think about that as you're doing this type of work. It's not easy, but it's kind of cool to watch these guys break these boards down. And one thing that he didn't mention, what he has is he's able to read the schematics really well. And so as I'm looking at certain boards, you can always download schematics. You can always download schematics. You can always download some schematics down, and just before you kind of start or you're going through it, look through your schematics and so that you can understand exactly where certain components and certain things need to be on your board. And it'll just kind of help you with the flow and what needs to support and what doesn't need to support. And you should be good. So, okay. So let's continue watching this guy, and here comes the soldering process. Flux there. Get it off there. As you're watching, you can see he is taking out the old component, the old resistor, and he is putting in the new one as it goes. And these resistors are, like I said, it's just a practice after practice after practice. And I know I'm not that good at putting these on there just yet, but we're going to get there.
Okay, we have soldered the 22 kilo ohm resistor right here, which is responsible for the audio codec, bass, or whatever is related to the sound. We have soldered 22 ohms resistor right here, soldered a couple of resistors, the 1 kilo ohm resistor here, 10 kilo ohm resistor here, 2.55 resistor over here. So I grabbed this resistor from the donor board since I don't have a resistor of 2.55 kilo ohms. This resistor should be precisely this value, so I have 2.4 and 2.6, but that's the resistor divider here, and it provides exactly 1.5 volts to the some pin of the SIO, and this pin is 5 ESB detection. I guess we can try to power on and see if it helped. Before we power the board on,
what he did, and if you, like I said, the soldering process, as you're doing the soldering process, that seems to be, you're going to have to really master that soldering process. If you don't know how to do it, you can always send it to someone's really capable of doing it. If you're not comfortable with that, what you're going to have to make sure that you have some tools. You can see he had little tweezers. He had his microscope to make it a little bit easier as we get a little bit into this, and just making sure that we have the tools to tackle a lot of this stuff, because a lot of these components, if you look at them, you look at your board, they're very small, very delicate. And you just got to just calm yourself down, and you should be good. But it just takes a lot of practice. And one thing that I'm doing is I'm fine looking in my garage, and I'm looking for boards that that don't work or whatever, and just taking components on and off, and just working on your craft to get better at your soldering and whatnot. It just takes time, and it just a lot of times we don't want to put the time into it, but if you can see, as I was talking to someone about this today, my son, he was mentioning, like, man, there's a motherboard in this, there's a motherboard in that. We're in the midst of building a steering wheel for one of his video games or whatnot. And I said, well, there's a motherboard in that we're going to have to deal with too. So it just takes time and takes energy. All right, let's get on here.
Let me give you my review. So now about the cordless soldering iron from NearC, which they provided free of charge for a honest review. I was skeptical about cordless irons going in, but being honest with you, I'm impressed. We repaired this entire motherboard with this iron alone. No hot air, no station, and I never turned it off during the repair. It still got more than 2/3 of a charge. I wouldn't replace my station with it, but this is a must-have tool if you do repairs on the go. Power outage or bulky electronics you can bring to the bench. Say you've got a large TV on the second floor and you need to replace a fuse on the board. In that situation, this iron is a real time saver. One note, there is no tool included to change the tips. So I'm not sure how often you need to swap tips in the field, but if you do, something for that would be handy. Overall, a very useful tool if you repair electronics on the go, if you've got projects here and there, or as a backup iron if you get frequent power outages. Links down in the description so you can check this iron out yourself. Trust me, if you do any soldering, this thing is worth a look. Okay, so let's power it on.
Yeah, one of the things that you're going to have to make your soldering iron, I noticed he had just that one. He gave it a pretty good review. The tip on it, that's the thing that I always seem to struggle with, is just keeping that tip nice and clean. And on this one, he says he doesn't know how he would change the tip in and out. There's got to be a little tool to it. But as you are experimenting with your tools and whatnot in your craft, make sure that you put, each day what I'm doing is I'm putting in some time of soldering things and using certain tools that work for me. Now, the tools that may work for me may not work for you. So it just varies on the person. It just varies on certain people. There we go.
And see what happens.
And as he puts his standard, he put his memory in there. He's got his 24-volt pin. He's got his CPU hooked up with that one stick and that A2. Then he probably has something so he can look for a post going to his monitor. So, and then let's see, most likely he'll put something on the little switch to start it up.
Okay, power on the board. Whoa, 258 milliamps. That's way too much, I guess, but who knows. So let's, the post screen gonna be here, pressing the power button. And we have, oh, okay, so it rebooted. I need a heatsink. Okay. 2.6 amps, and will we have a pause screen? Come on, that's it. So the problem was in those knocked off resistors. Let's see, what do we have in the BIOS? And we have a BIOS of 2022. So it's kind of outdated a bit, but I'm so glad that we fixed this board. I guess that the main problem was in the SIO resistor, which basically broke in the past for the 5 VSB detection. And let's see if it will power off within the button, and it will normally. Cool. So another problem was in the audio codec, so that's what we will have to test as well. But in overall, I guess, so this board is fixed, and I'm so glad with it.
Well, as I look at his as he fixed his board, and one thing that you're going to have to do is make sure also have some, some spare components aside. And that's one thing I'd start doing is stockpiling some resistors, and so that I'm ready to go. The main thing, as I look at a lot of these YouTube videos and these guys repairing stuff, it's just practice. It's just practice. It's something you're going to have to do, and you're going to have to just sit down and work on it and practice it every day. And as you are practicing, it's just do this, step 1, step 2, step 3, and then do it over again. I know it gets boring. You want to do it a different way, but let's stick with things that are working. You apply this, you apply that. I know we want to make it sound like we were doing some miraculous stuff with this, but everything's just kind of trying to keep it 1, 2, 3, 1, 2, 3. And as we watch this video, let's break down what he did to solve this problem. First thing he did was he checked the voltages and the ohms and make sure that the board was not shorted out. He went through and he looked at certain components, the major components, to make sure that they were there, they were intact. Second thing he did he did a physical appearance of the board, how it looked, how it was responding, and let's look for anything that was this abnormal. He did a little notice, and what I call it a notice and wonder. What do you notice? What do you wonder? Why is this not right? Why is this not there? And then after he did that, he realized, okay, let's take these resistors that are broken off. I don't know if it could be part of the problem. He did that, and he checked them. He took them out, unsoldered them, soldered them back in there. And then last thing he did was he set it up where he was looking for a post so it can get to the BIOS. So most likely what he says he's going to do is test it out a little bit more and put a little stress test on it. And then he said, but the main thing is he's glad the board works now. And so, like I said, it's like 4 little stages he went through. And it's kind of interesting. Like I said, the more that you watch these videos, the more that I watch the videos, the vocabulary, the things that he is saying, you're going to start understanding a little bit more. So I know when you first get into this stuff, it's kind of overwhelming for a lot of people, but we're going to stick to this. We're going to stick around. It's a good little business to get into. It's something good to know. Like I said, if you have a multimeter, find your little multimeter, go to a local store, get your multimeter, and you're ahead of a lot of people down the road. So continue pushing yourself, continue enjoying what you're doing. Like I said, this repairing stuff, it's kind of the things that I like to do. It's interesting to learn more, and we're going to continue this series and learning and getting better, and that's all we can do. So thanks again. Make sure we like and subscribe, and we'll see you on the next one. All right, bye-bye.